Great. Well, thanks everybody for coming. It's great to see so much interest in network device automation. Now, just so we can get an idea of people's backgrounds in the audience here, could we get a show of hands if you're either a network engineer or you're otherwise responsible for the configuration of your network devices? Okay, that's a good representation. And then how many of you are familiar with Puppet? You don't necessarily have to be experts, but you make use of it. Ah, excellent. All right. I have a couple of brief slides about what Puppet is, but obviously this is not going to be a tutorial about Puppet. We had a really great turnout, I guess, at our Intro to Puppet session the other day. And so, for the few of you that aren't familiar with Puppet, we'll give you a quick overview, but we won't be spending too much time on that. Also, some of the stuff we're going to be talking about is going to be fairly high level or probably applicable to people regardless of what tools you use for network automation. But obviously, anytime we go into specific examples, we're going to be talking about how we do things with Puppet. So at Puppet Labs, we've been working to extend our configuration management tools into the network device arena. And our goal for that, our vision for that, is to enable you to manage your networking configurations in the same way that you're currently able to do with your server and application configs. And the benefits that you get from this are to be able to manage your infrastructure as code. This is one of the basic tenets of the DevOps movement. So the purpose of this talk is to give you an idea of what it means to begin managing your networking configuration infrastructure using Puppet. We're going to be talking about a little bit of where we're currently at with our network device support and also some things that are around the corner in terms of upcoming support. And we are going to talk a little bit we'll go into a few examples of network manifests that configure networking devices. But the goal of this is not to make you all experts in how to write networking manifests with Puppet. But the goal of this is to definitely make sure that you're all able to leave here with a very clear idea of where you need to go next in order to begin trying this out on your own networks. And then also importantly, we're going to be talking about where we see the future of network device automation, and especially where we see some of the cross-vendor configuration standards converging to, and how we intend to leverage our support of that at Puppet, or evolve our support at Puppet in order to leverage that. So just briefly about myself, my name is Scott Garman, and I work on the release engineering team at Puppet Labs. And I tend to work with a lot of our partners as we add new supported platforms for our Puppet agent software. That's the client-side software that actually runs on the end node. I actually don't have much of a background in network engineering, but I'm more of a embedded Linux developer and distro engineer. But this has turned out to be a pretty handy background to have when working with a lot of these networking devices, which are very frequently based on customized Linux distributions. I work out of our Puppet Labs headquarters in Portland, Oregon, and I really enjoy being part of the thriving open source tech community that exists in Portland.
Hi, afternoon. My name is Rick Sherman. I'm also known as Shermdog. I'm a fairly recent addition to Puppet Labs. I joined over the summer. I came from a large network vendor previously. My focus here at Puppet Labs is expanding our network platform coverage. I work with a lot of our customers and partners to understand how we can best suit them as we move more into the networking arena.
Great. So just briefly about Puppet itself. So Puppet is, a tool for configuration management and also application orchestration, making sure that when you're deploying your applications, that services get restarted in the correct order and make sure that things can be deployed in a more complicated manner. And the purpose of using tools like Puppet is to make sure that you can increase, things that are valuable to an organization, like your consistency, reliability, and ultimately the velocity of how you can incorporate changes in your IT infrastructure. The key thing to keep in mind about Puppet, the language itself, is that it is a declarative language. It's not like a procedural set of scripts that you're writing to, control devices. But what you're basically doing is defining the end state that you want your managed nodes to be in. And the Puppet software takes care of taking a look at the current configuration of your nodes and then bringing it into compliance with the desired state that you've defined in your Puppet manifests. But we do have some language tools such as inheritance and ways to classify nodes to say that these are your production Apache servers or your test Postgres databases. And ways to flip systems between that. And we have a pretty healthy ecosystem of code that you can reuse. These are Puppet modules that you can find on the Puppet Forge, which is at forge.puppetlabs.com. And these are modules that you can use for managing things like your NTP service, or, like I said, standing up a Postgres database or things like that. We've got over 3,700 of them to date. Puppet's been around for a long time. I'm sure many of you are familiar with the open source edition of Puppet, and some of you are probably also users of our enterprise edition of Puppet. And it's a great tool because of the openness of it. You can get started with it very easily, evaluate it, and see if it's useful for your needs. And then for folks, especially who have very large deployments of Puppet, a lot of the tools that are included in Puppet Enterprise that you don't get in the open source edition are intended to make your life easier when you have like very large scalability issues, or things to make things more convenient for like node classification and so on. This is just a kind of a diagram of the workflow that occurs with Puppet. So you have a Puppet server and then one or more nodes that you're managing. And on the server is where you're maintaining your Puppet manifests. And the nodes check in to the server on a regular basis. By default, this is every 30 minutes. They send over facts, which are kind of platform identification facts about the device. And the server will then compile what's called a catalog, which is that desired state that you want this node to be in. The node then takes that catalog, compares it to its current state, and applies any changes as necessary. And generally does so in a way that's idempotent, meaning that there are no side effects. You can continue to apply the same desired configuration and not end up with other side effects. And then after the node makes those changes, it reports back to the server, and the server can generate things like reports on what things have changed in these nodes. And you can evaluate that and say, okay, this is what I was expecting or wasn't what I was expecting, and get useful information out of that. That's it in a nutshell. There's a lot more to it, but those are just the high-level details. What I would suggest if you are new to Puppet is to check out our learning portal here. This is at learn.puppetlabs.com. And there's a lot of really useful resources. I think one of the most popular resources for folks who are new is our Learning Virtual Machine. This is a VirtualBox or VMware compatible VM that you can download. Then you boot it up, you log into it, and there's a whole series of quests that will bring you through your first steps of writing Puppet manifests or making use of modules. And it's a really highly critically acclaimed tool that we've had for folks. It was what I actually used when I first started using Puppet. And it's free to use, so you can just go to the site and download it. We also have some self-paced online courses. This is useful if you are familiar with Puppet, but there are certain topics that you want to level up on. And then we also offer instructor-led training and a certification track, and you can learn all about this at this learning portal. So that's just a quick overview of Puppet and what it is, and now we can go into more of the networking details.
Yeah, so based on the audience here, I think you guys will be able to keep me honest on this, but I want to speak a little bit about what it is to be a network engineer. Networks are increasingly complex. They are providing services over a multitude of devices. Generally, they're heterogeneous. It requires a lot of time to plan, to test, to deploy, and to configure these devices. Network engineers, unfortunately, have to also spend a lot of time firefighting. Problems are generally not very intuitive. Logs are difficult to parse. It's often trying to look for a needle in a haystack. There's also a lot of mundane tasks in networking that really bog us down. We're doing daily changes to support other parts of the business that we may not actually have a full understanding of. So in a lot of ways, this is exactly like what system engineers are doing. But we have some things that are special. Network devices historically have been closed systems. They have vendor proprietary CLIs. Those CLIs are going to differ between the vendors as well as between devices even within the same vendor. The configuration on these devices is hundreds, if not thousands of lines long, and this is per box. And even if we actually have a configuration on these boxes, it doesn't guarantee that our desired state will be achieved. Oftentimes, we're actually peering with other partners or other networks that are not under our control. And if there are some cool new features that the vendors are going to release, it generally takes them 18 to 24 months to roll out. And when you couple that with the fact that it takes an incredibly long time to test and deploy new features, it's often upwards of years before something ever sees the light of day. And a lot of network engineers, generally speaking, don't have a systems administration background or programming background. So a lot of the tools and techniques that are available in the DevOps world are actually fairly new to network engineers and kind of met with some skepticism. So up here on the left, we actually see an example of what a common switch architecture of leaf and spine looks like. And if you imagine if you scale that out to hundreds or thousands of nodes, just keeping track of the physical connections alone becomes pretty much of a nightmare. In the lower right-hand corner, I'm actually showing an example of a BGP leak. So here's an instance where a third party outside of our control made a mistake. They misconfigured something and took the routes away from Amazon Web Services for over half an hour. So I mean, the impact of this was millions of dollars, and it was on a simple mistake. So when we try to manage these devices individually, we mentioned hundreds of thousands of lines. It sucks. Trying to do this by logging into a CLI is not scalable, it's not reproducible, and really, it's just unpleasant.
So I'm sure you're all starting to think, okay, how can I get started with this? Where can I get started with this? Which of my devices are currently supported? So at this point, I'm going to go over an overview of the supported networking devices that we have and also what's right around the corner in terms of support. One thing I will mention here, since I am in some cases talking about potential future things that will be released, is this kind of disclaimer that says basically you can't hold me to it. This is all basically based on my best knowledge currently, and as we all know, software schedules sometimes slip. So going through the vendors that we've been working with in alphabetical order, first we have Arista Networks, and Arista has an operating system called EOS. And what's nice is they use this operating system throughout all of their devices. So if you go to Arista's site and you take a look at their list of switches, you'll see that they're all running EOS, and we basically, our support is based on EOS since version 4.13. And this includes switches from top-of-rack switches to kind of larger chassis-based switches as well. So we've got support for this whole range of the devices that they currently offer. And this support is compatible with Puppet Enterprise 3.7.2 and later. I believe everything I'm going to be talking about here is also compatible with open source. It's not PE only, but I'm including here the Puppet Enterprise release that it was first included with. And this is a Puppet supported solution, meaning that if you are a Puppet Enterprise customer, you can call up our tech support and get help with configuration. To do that with the Arista devices, you have a choice of two different modules to make use of. So these modules are both available on the Forge. There's the Arista Networks /EOS module, and that's a module that Arista basically wrote from scratch. And then there's the Netdev Standard Lib module, and we're going to be going into a little bit more detail about what Netdev Standard Lib is. But basically, in a nutshell, it's intended to be a cross-vendor compatible, kind of lowest common denominator set of Puppet types that can control network device features. So some port configuration and other things along the lines there. And the potential value that you get from that is that you have potentially manifests that you can write and then apply to devices of different vendors, models and brands and so on. Of course, the vendors have to support the NetDev Standard Lib types. And in the case of Arista, you have a choice between those two, so whatever suits your needs better. When it comes to Cisco, we recently announced our support for the Cisco Nexus lines. So these are the 9K and the 3K series switches. This came out just a couple months ago in September, and it's compatible with Puppet Enterprise 2015.2 and later. On the open source side of things, that corresponds to Puppet 4.0 and later, because that's when we made the change to the language there. This is a Puppet supported solution, and most of the work that you'll find is in the Puppet Lab /Cisco Puppet module. And this module is under pretty heavy development. I know, in fact, there was a new release of it this week that included some new BGP features that had been missing previously. So Cisco is primarily the ones writing this module, but it's a collaborative effort. And there's a lot of stuff going on, and future support for additional Cisco models is going to be going into the Cisco Puppet module. So it should be your kind of one-stop shop for Cisco support. I'll also mention, too, that there's an ACI configuration module that you can find. This is out on GitHub. We don't have it yet on the Forge yet, but we are working with Cisco to get some things taken care of to to get that in a supported module. So there's just some things that need to be fixed, but it is our intention to make that a supported module as well. Can we take questions now, or I think we had the person back there?
A question, does the Cisco Puppet use the same NetDev API, or is it different?
So what Cisco Puppet has its own types, and we're actually right now in the process of adding the NetDev types for it as well. So you'll have, again, the choice in that matter.
And some of those actually came out in this release this week.
Yeah, some of those, again, kind of keep an eye out on the GitHub repository. So, the work is ongoing right now. So. Also, when it comes to Cisco, I know a lot of folks or I should say that the 5K, 6K, and 7K series switches are more popular in the marketplace right now. Work for that is ongoing right now, and we expect it to be ready in Q1 of 2016. Cisco has been a great partner working with us, and so they've been doing some additional testing and validation on it, and they are promoting this as a Cisco-compatible solution. And if you want to learn a little bit more about that, Cisco has a Puppet web portal you can find at cisco.com/go/puppetlabs. We also have work with Cumulus Networks. And Cumulus, if you're not familiar with them, they do things a little bit differently. They don't actually make their own network device hardware, but they make their own OS, which is actually based on Debian Linux, which can be run on white box switches. So you can run Cumulus on, say a Penguin computing switch or a Dell or an HP switch. If you go to their website, you'll find a hardware compatibility list, which lists all of these devices. And the Puppet support is currently available for all the x86-based switches. There are some PowerPC ones as well, but right now the support is based on the x86 models, and is available with Cumulus Linux 2.2 and later, and working with Puppet Enterprise 3.7.2 and later. These are also Puppet supported, and what Cumulus did is a little bit different. So they have different modules that they split up in terms of functionality, in terms of all of their interfaces. So we have Cumulus ports, Cumulus interface policy, a separate module that you would use for licensing management, and so on. But because Cumulus is based on Debian Linux, if you want to manage something, say like NTP, you don't actually have to use the Cumulus module for that. You would just use the Linux, NTP based module, and that would configure it on a Cumulus device. The fund isn't just limited to network switches. We also have been working with F5. They have their Big IP load balancer series that you can control with Puppet. And that's been available with Puppet Enterprise 3.7 and later. And what's kind of unique about this too is for the F5's load balancers, we're not actually running the Puppet agent on the nodes themselves. We have something else called Puppet Device that we use instead. And so what Puppet Device is, it's like a little server that you set up, and Puppet manages the Puppet Device instance, and that Puppet Device instance then proxies network-based API commands to the end device. So in the case of the F5, it works over a REST API. And this is something that we offer as an agentless way of controlling devices with Puppet. The F5 module is Puppet supported, and you can find it on the forge under the Puppet Labs namespace /F5. Another question?
The proxy server, can that manage other devices like Cisco switches that are not currently supported?
Could you just repeat it with a little closer to the mic?
Could this proxy server manage, for instance, other Cisco devices that are currently not supported, like older switches or something?
Correct. Like some of the like the Catalyst series, for example. Yeah, that's what we're looking at is in terms of supporting those kinds of devices as well. We don't have an officially Puppet supported solution for that just yet, but that would be the way to go about it because we can't get an agent onto the iOS platform. Right. And then another question up here.
So actually, it's just a continuation of his question. The Catalyst switches also don't have any REST API or anything as such.
Right. Do you want to talk?
Yeah, actually, so some of the CATs, like the 6500s, I want to say the SOUP 2Ts and above, actually support netconf, which we're going to talk about a little bit later here in the talk. So we'll kind of discuss that at a high level, and then we can discuss it a little bit more one-on-one afterwards if you like.
And I think maybe from this point on too, maybe we just hold questions towards the end, just for a flow reason. We appreciate the questions, and we'll have some time for these at the end. I don't think we're going to go anywhere close to time limit on this too. And then finally, so in terms of the supported devices, we're also working with Huawei on their Cloud Engine 12800 series switches. And Huawei is working on their next release of Huawei OS, which is 6.0, and that's what will have the Puppet support. And what's kind of unique about the Cloud Engine switches is that Puppet Agent will be OEM installed from the factory, and so that'll take out one step for your initial deployment. So it's kind of a unique feature of them. They will be Puppet supported as well, and we're looking at them in the beginning of 2016. Uh-oh. Did we lose network? Oh, there we go. Okay. So that's a quick overview of where we're at in terms of network device support.
Yeah, so as Scott mentioned earlier, there are kind of two different ways that Puppet types are compiled for network devices. We've got the Netdev Standard Lib, which is generally high-level type of configurations, and then we've got vendor-specific ones. So I'm going to take an opportunity to kind of go through those now. So as we look at NetDev types, they're fairly standard types of things, such as NTP, syslog, basic interfaces, AAA, and SNMP. These are things that you would commonly find on most any device and are fairly important to get up and started. As we look at the Arista vendor types, we see some things of, such as BGP, MLAG, VXLAN, et cetera. But what I want to call it to attention here is the highlighted EOS command. So in instances where we do not have an idempotent type defined, we can actually arbitrarily pass CLI commands directly to the device. Effectively, this is a crutch until we're able to get more of these types defined and provided. Similarly with Cisco NX, you also see BGP, that was added this week. They have OSPF as well, and some VRF and SNMP and TAC types. They also have a crutch or a big hammer, which is the Cisco command config. And we're actually going to go over an example of that shortly. Going to Cumulus, they're actually a fairly small list of vendor-specific types. As Scott mentioned, these platforms are based on Debian Linux, so any of the standard Debian modules will actually work directly with this device. So these are predominantly just the interface things that we need for Cumulus Linux specifically. So obviously that was a quick run through of those types. So a lot of you are probably trying to figure out how we can get started with this. Generally speaking, as engineers, at least myself, I like to try to boil the ocean. And at Puppet Labs, we try to help you start iteratively. So generally speaking, we suggest you stand something up in your lab if you can, and start something small like syslog or NTP. These are services that are important to get started, but may not be service impacting if something goes sideways. So here's an example of some Puppet code. This is going to configure NTP on an Arista device. So we're including the EOS role. We're ensuring that Puppet is installed and running on the device, which is important for this. And then we're actually setting some specific things here, such as the management interface for our NTP source, as well as NTP servers that we want to peer with. Looking at Cisco Nexus, we're actually using the command config here, because previous to this week, we didn't actually have the NetDev type installed. So we're actually passing in a list of arbitrary CLI commands directly to the box. It may or may not be idempotent based on the receiving box, so your mileage here may vary. Going over to Cumulus, again, we're ensuring that Puppet Agent is installed and running, like we did with the other two, but here we're actually using the standard NTP module. So this is the same one that you would use on any common list of servers, and we're configuring it as such. So moving on a little bit more network-centric, we're going to show you a few different ways to do Vlan Trunks. So here with Arista, we're choosing one of the switch ports, in this case Ethernet 48. We're setting that mode to trunk, and we're actually passing in a range of VLANs that we want to trunk, as well as some static ones. And then lastly, there's a native VLAN that we're putting into that trunk. The Cisco one looks very similar. Here we're using the same Ethernet interface, setting it to trunk, passing in the range of VLANs, and our native. Lastly, again, the Cumulus, it looks almost exactly the same. The only thing that's really changed between these three is syntax, and part of that is an artifact of having these vendors produce their own types. So they try to have some similarities, but unfortunately, they are unique in and of themselves.
Great, so this is just an overview of so the steps you're going to go through as you want to get started with this. So the first thing is check to make sure that your networking device is supported. I imagine these slides will be made available after the fact, or if not, you can email one of us and we can give you a copy of them so you can have that for reference. And download and install the Puppet agent for your platform if it's required. And the documentation you can find for that should be available if you go to docs.puppetlabs.com and then do a search for the network vendor. So for example, Cisco, one of the first hits that you should get on that should be instructions for how to install the agent for that platform. And then based on, in some cases you have choice, but grab the module for your device. Again, if you go to the Puppet Forge and you do a search for the vendor name, you'll find one or more modules that you can make use of. And then, as Rick was talking about, begin with a simple task. When people get started with Puppet, we don't say, start managing massive, service infrastructure, but begin with something small like NTP or syslog. And then as you get more comfortable with that, then you can move on to more advanced features, such as, getting down to managing things like network ports.
Yep, so as we alluded to just a few moments ago, I want to spend a little bit of time talking about the efforts in networking to come to more commonality and have more management interfaces cross-vendor. So a lot of our standards bodies have been working pretty hard to come up with solutions to the age-old vendor proprietary problem. And a key tenet of that currently is netconf. Netconf has been around for a long time. It was ratified by the IETF as a network management protocol. It is XML-based, and unfortunately, there are no guardrails as to how that XML should be formatted or what the content of that XML is. But it does include some standard sets of RPCs. Now, predominantly in the configuration side, you're able to do things like retrieve the configuration, set it, lock it, unlock it, etc. And also it supports operational RPCs. Generally speaking, these are ones that will map to CLI show commands, so you can actually get the operational state of a device after it's been configured. Your mileage will vary significantly on this based on the vendor. Also, historically, netconf has been transported over SSH, although we're starting to see a pretty big shift over to HTTPS or RESTconf. In addition to netconf, the IETF has ratified Yang, which is a data model language for netconf. You're starting to hear a lot of network vendors speak about this. What Yang is a human-readable representation of netconf data. So they've compiled a set of known data types and node representation so that we can actually view this netconf data in a more human parsable way with some sane guardrails regardless of vendor. Unfortunately, it is vendor proprietary, so the content of a Yang model will be based on that particular vendor, but it's also extensible so that if there are industry standards or customer models, they can be extended on and inherited across various types of models. So because of this, some of the standard bodies such as the IEEE, IETF, Cable Labs, and also industry partners such as Google, AT&T, and Apple have been pushing for OpenConfig, which is a set of models that are going to work cross-vendor. So if you want to participate in any of these sorts of large networks as a network vendor, you need to now support this model, and it can be used regardless of device type.
Great. One thing I'll add to when it comes to the netconf and Yang discussion as well is, so we have this Netdev Standard Lib set of Puppet types that we're trying to create as a kind of a cross-vendor standard. We recognize that looking to organizations like the IETF or the IEEE for larger standard bodies for this makes a lot more sense in the long term, and I can see us trying to evolve our support to reflect that better. And one example of that is in our collaboration with Cisco, as they were looking to add the BGP support to the Cisco Puppet module, we were discussing with them, looking at the IETF's definition for BGP. And our intention is also to take that, that kind of layout of, or that structure of those Puppet types and then add that to the NetDev Standard Lib as well. So we see that, as a way of kind of trying to leverage that kind of like higher level industry support, and it's something that we want to take advantage of, as much as possible. But the important thing to keep in mind is this is very much a learning process for us, and we want to hear feedback from end users for this. When it comes to some of the Yang models, for example, you might think it might make the most sense to just create some sort of translator that just takes the Yang model and then translate it into a set of Puppet types. But in some cases, that may not work well from a usability point of view. You might just get a bunch of spaghetti, types, and we need to take that into account. That's something that we care about at Puppet, is that end user experience as well. So that might be a reason that there might be some differentiation between just going straight with, a Yang definition and the Puppet one. But we want to hear from you, and especially as you try to get started with this, what your experience is with it, where you feel the priorities should be, whether it's in terms of network device support or how we're doing things in standards like NetDev Standard Lib, or just other feedback in general. So our contact information is here. We'd definitely love to hear with you, and of course we'll take some more questions. But yeah, that's thanks for coming by.
Yeah, hi. I have I have two questions actually. So we have a bunch of Dell previously Force 10 switches, and they claim integration with Puppet. And I didn't see them up there. Is that because maybe you guys don't know, or maybe you don't have experience, or some other reason? That's the first question.
Yeah, so the Force 10 devices, Dell actually compiled their own Puppet agent, and that's based on our open source. So unfortunately, that's not something that Puppet Labs is certified. And so they're essentially doing that like any open source customer would. But we are in active discussion with them to try to move that forward.
Okay, thanks. And the second question is, and maybe you've thought about this, but it would be really useful if you had some sort of sandbox, like if I run this set of commands on this, what is the config going to look like afterwards?
Yeah, that's also some feedback we got from Cisco Live this year. There is the Puppet no-op, which is kind of a good representation of it, but from a network engineer standpoint, it's not really great. And in the industry as a whole, we're also now starting to see a lot of virtual machines. So it may actually be an instance where it may make sense just to apply that directly to a VM as opposed to parsing it out, but that's still kind of up in the air.
All right, thanks.
One second.
To that point, just as a suggestion, instead of having to run a VM or something, could you just do a diff of what the config would look like if I applied this set of changes? Just give us the actual Arista show run difference.
Well, part of that actually depends on the provider that the vendors have written. So like, for example, if you were going to do that for an F5, they're actually using a REST API, so they may not actually be parsing that down to configuration itself. So it is a little bit weird where you almost have to configure it to get the end result back. So that's kind of those idiosyncrasies that we're trying to work out. But I do appreciate that feedback. It's infectious.
You mentioned Cisco Nexus. Do you have any plans to support iOS?
How do we answer that?
I guess all I can say is that there's nothing I could speak about at this time, specific with regard to that. No, but yeah, one issue we have had with the iOS stuff is that we can't get the agent on the device itself. So any solution to that would have to be based on a Puppet device.
At least legacy iOS.
Yeah, at least legacy iOS, I should say.
What about Juniper?
Yeah, that's actually a kind of a similar answer. So they actually do have a Puppet agent on the older EX series. It was kind of compiled off open source. It's currently stuck because of their version of GCC doesn't allow them to go to cFactor. We're also in active conversations with them about how to move that forward. I can't really tell you which way we're going to go because it's pretty fresh, but that's actually where I came from. So.
One more question. So the Puppet agent, on the devices, I'm familiar with NXOS, so I'll stick to that. So is it always running, or you have to invoke it? And is it intrusive with your normal operations, like if you're in the device?
That actually runs in the normal cadence, doesn't it?
Yeah, it runs every
Yeah.
30 minutes or so. Yeah. The agent can be run like from cron if necessary, but yeah, normally it runs like as a system service daemon, and then wakes up every 30 minutes in order to communicate with the server.
So you started off the presentation saying vendors are very slow, and you seem to have taken the approach of waiting for the vendors to make agents that work on their devices. I'm just kind of curious why you're not maybe going the Puppet device approach where you can start interacting with APIs or SSH and get more coverage of devices much quicker. Because there's not only this Cisco and the legacy iOS, but there's also multiple firewall vendors, routing, all these other network gear. We've got 100 switches there, and there's probably thousands of pieces of network gear, and you're giving us like 5%. So I'm kind of curious why you kind of took that approach instead of something that could be scaled a little bit faster and be, I'm able to then get the whole network under Puppet.
Right. Well, part of it is kind of a domain knowledge issue. In a lot of cases, working with the vendors for them to write the module makes sense because they understand the workflow of their customers and so on. But we have been trying to increase our expertise within Puppet. Rick just started this year as part of the team, and he has the kind of network engineer background and in the vendor background. And so we're hoping to look for more opportunities like that to expand it in the future, but we need to do it in kind of a scalable way. We can't necessarily have a massive team devoted to that at this time. But so the easy way for us is more to have the vendors who want to work with us, and most of the vendors want to work with us at this point, to see what their product roadmaps are. And generally, they're more interested in making sure that the automation is supported in kind of their newer products that are coming out, because that's a feature that they can sell to you as well.
And actually, what I'd also like to ask, if you do have these devices and you are a Puppet user, to kind of start giving us more feedback. Obviously, we don't entirely know what that marketplace is right now. What may not be the most important thing to you may not be the most important thing to us. So we actually need that feedback to help our product people decide what we're going to tackle next.
One criticism that I had, we ended up going with the Juniper solution, but partly based on them saying they had really good Puppet support. We ended up finding out it was really half-baked. So I would love to, if maybe Puppet Labs can maybe perhaps do a better job of, I think you did a good job here of showing which ones are supported, but I'd love to see a little bit more like, yeah, and these guys wrote theirs and we haven't tested it really, and we have no idea, and maybe it's, maybe it works, maybe it doesn't. Juniper's ended up like, you had 2 trunks and then it stopped working. Just like really fundamental things. Like some of this stuff has been fixed since then. But it would be great to be able to make better business decisions early on before you can play with them about what the level of support is and the rigor behind it before you make those decisions.
No, there's not actually really a comment to follow with that. That's great feedback. So.
Okay. Do we have any more questions? In that case, thank you very much.